Hi everyone, we're going to start our PARCC tutorial series, and this first question comes from the Algebra 1 exam, the practice test that is on the PARCC website. So even though we haven't been working with exponents yet, we have been doing quite a lot of work in our class on combining like terms. So let's start with what we know about like terms. And there's two things that we've identified in class. Hopefully when I say them, you already know them. But the first thing we focus on is the same variable. And the second thing that we want to make sure of is that we have the same exponent, because we know that x and x squared are not the same thing. So we can't just combine them. We can't just add everything. So when we first look at this expression, we see that every term here has an x. The difference is not all of them share the same exponent. So that should give us a hint as to what we're going to combine. The next thing we want to focus on is our parentheses. When we have our parentheses, we want to simplify first. These parentheses here don't really serve much of a purpose because I cannot combine my x to the fifth and my x to the third. I can't combine them because they are not like terms. So this parentheses here doesn't need to be there. My dog is barking, sorry. But this subtraction symbol is going to do something. Now we talked about this in class just the other day, and that is actually a -1. So if you think about what we have right now, we have 3x to the fifth, and it's hard to do this without a pen because I am just dragging my mouse at my computer. But this second parentheses actually represents, hopefully you know it, and I don't have to say it, but I will anyway, our distributive property. -1 times 7x squared is a -7x squared. And -1 times a -6x to the third is plus 6, sorry about that, x to the third. That's a weird 3, sorry. So now looking at everything, I can combine my like terms. Hopefully we identify, if we remember what we know about our like terms, same variable and the same exponent. That's the key here. So our like terms would be our 8x to the third and our 6x to the third. If I combine them, I do have 14x to the third. Now hopefully if I ask this question you'll know the answer, but my next question would be, can I combine the 3x to the fifth, the -7x to the second power? Can I combine any of them? And the answer, again, looking back to what we know about like terms, the answer is no. They don't have the same variable and same exponent, so I simply write them as part of the expression. So now looking over at my solution here, we should identify, hopefully we do, that these three terms here cannot be combined because, like we've been saying the whole time, same variable, same exponent for our like terms. So now we have to go to our answers and see which ones work. This first one does not work because it just doesn't represent the variables that we have. Hopefully you see the second one doesn't really make sense. And it looks like C is going to be our solution. It really doesn't matter here that the 3x to the fifth and the 14x to the third are in a different order. That is the commutative property that tells us that you can add things in any order. It would still give you the same solution. Just like we know 5 plus 2 is the same as 2 plus 5. That's the commutative property. So there you have it. That is our first PARCC tutorial, and for those of you that may not think that you are prepared, you just solved the first question of many from the Algebra 1 PARCC exam. And again, this is featured on the Algebra 1 practice test, which can be found on the PARCC website. We will have videos like this hopefully every week, if not every few days, so that when you take this exam in the spring, you are comfortable with all of the types of questions that you may see. If you have any questions about this or any comments, please comment on this video. And if you haven't yet subscribed, students, please subscribe, because once we get to 100, we can change the web address of our YouTube page. Hope everyone has a great night. Thank you for watching, and I will see you all bright and early tomorrow morning. Bye.